Okay.
Yeah.
Now, all right, with this one, guys, we are starting our other type of proofs. All right. I told you in this class you're going to learn 3 different types of proofs. You're going to learn direct proofs based off of our logical arguments. And I told you you're going to do algebraic proofs based off of algebra rules. And we have to apply it in geometry as well. And then you have geometric proofs. You're going to have all of those by the end of this unit. Now, I'll tell you right now, I don't expect you to be good at geometric proofs at the end of this unit. You'll get good in the next couple of chapters, okay? But we're going to get all of them. But the rules and stuff will stay the same. So once we get through the rules and things for algebraic properties, we then can go on and we can just do proofs galore, and you're going to find out how easy they are. I think algebra ones are the easiest ones. Are you guys with me on that? But we need to remember a few things. A few things you need to know. It says algebraic properties of equality. So what symbol do you expect to see in there? You need an equal sign. And we're going to use the fact that A, B, and C are real numbers. So we need them to be real numbers. So all of these, I'm going to write the name of it, the middle one's like the formal definition, and then I'm just going to write an example of what it looks off into the third column. Now, guys, you do this type of stuff all the time. You just don't call it this stuff. But here's the problem. When you're doing a proof, any type of proof in mathematics, you have to show every detail. Because if you don't, and someone questions that detail, your proof won't be considered true. That's why mathematicians are really cocky, okay? Because they're always right if their proof is correct. Scientists can't ever say that, so don't tell them I said that. But scientists can't ever do that because they can just do an experiment over and over again and they see a pattern and they think that's true. Mathematicians say, this has to happen or it won't work. And they go to all the other coworkers and mathematicians around the world and they say, try to disprove me on this. And if they get disproven, then they have to go back and try to figure it out the right way. It's a really big deal. So when you do a proof, we're doing a very microcosm, a very small part of that. But it's the same thing. You can't have any gaps. You always have to have an explanation down. So with this one, we're going to start from the very basic properties that you use to solve equations. Are you guys with me on that? All right. So first one is very simple. It's called the addition property of equality. Now, to do the addition property, that does not mean you're going 1 + 1 = 2. That's not what I'm doing. I'm not simplifying. I'm not adding two things together in that sense. It means how you solve equations. For instance, if A equals B, then I know A plus C is equal to B plus C. This is the idea of solving equations. If I add it to one side of the equation, what do I have to do? Add it to the other. So it looks something a little bit more like this. If x minus 5 is equal to 10, then I know x is equal to 15. It's really using the fact that I added 5 to both sides, right? And that's why you get away without showing this, because everyone knows you probably applied the addition property for this. Not that. Then, if you have an addition property, you have to have its inverse, which is what? Yep, you have to do the subtraction property. And be the same start. If A equals B, then we know A minus C is equal to B minus C. So again, I'm going to subtract from both sides. And I'm keeping it really simple here. If x, let's go, plus 7 is equal to 15. Actually, let's go 2x plus 7 is equal to 15. Then what do we know next? 2x is going to equal... Okay.
I didn't know.
Hey, well, yeah. Like, how do you solve the equation? Wouldn't you have to subtract 7 from both sides? So when you see that, you really have always been doing this solving equations, right? We do that. In fact, when you first started doing algebra and pre-algebra, we would sit there and make you show the work, and eventually we were like, please quit wasting our time. Just do the process, right? So make sure you're able to justify it. Now, we did addition, subtraction. What was the next thing you learned as a kid? Multiplication. All right, so we're going to have our multiplication property. So with that, we'd have here, if A equals B, then A times C is equal to B times C. When would something like that show up? When you have an equation, that'd be something like x divided by 3 is equal to 6. How would you solve this? How would you tell a younger sibling how to solve that? What would you do to both sides of the equation? Multiply by 3. So then you know x is equal to 18. Because if I multiply with 3 on the left, the 3's simplify out to be 1. If I multiply the 3 on with the 6, then I know it's 18. And it'd be basically illegal to do otherwise. If you only did it to one side, not the other one, are you keeping your equation balanced? No, not at all. All right, next one with this one. How about division? I'm sure you guys are not surprised by that. So we have our division property. With this one, we have the following. If A equals B, then, oh, one thing I forgot, sorry. If A equals and, this makes sense, C cannot equal 0. Then A divided by C is equal to B divided by C. Why can't C equal 0? Can you divide by 0? No. What's your, if you try to divide by 0, what would you say that is? It's undefined. You know why it's undefined?
You can't define it as cubic fractions.
That doesn't, yeah, it's undefinable to think you'd ever try to do that. But here's the other way of thinking about it. It really, that's division, correct? 1 over, we talked about why you can't divide by 0 is 1 divided by 0. All right, can I go 1 divided by 0.00, let's go 10 million zeros and a 1 after it. Is that still divisible?
Yes.
What would that number be like?
Longest.
Really, really, really big, right? Because when you divide by really, really small numbers, you get really, really big numbers for answers. They are so big, it's undefinable. So if you try to divide by 0, the answer is so big, it's what?
0.
Yeah, you can't even describe it. It's so big. Does that make sense? So it's so big. That's really why they say it's undefinable. How do you try to describe something to put it into 0? Well, it's too big. I can't. It's kind of cool. It hurts your brain. Play on your calculator sometime, not right now. Sometime, and you can figure that out. All right, so what would be a quick example of this? Well, let's switch it around a little bit. What if I had something like this? 3x is equal to 6. Then x is equal to? Yep. All right, so basically we now can do basic solving of stuff, right? Now, there's some that are actually very important that you need to know. This one is called the reflexive property. Now, when you think of reflexive, a lot of people think of like reflexes, like when you're at the doctor's office and then you like tap your knee and you like kick your leg, right? That's not what I want you to think about. When you're thinking about reflexive property, I want you to think of the word reflection. All right, when you look in the mirror, who do you see? Yourself. If not, you have a weird mirror, all right? Like, you see yourself, right? So reflexive property, really the idea behind that is you're equal to yourself. Yeah, so the idea is if I know you're equal to yourself, simple as that. Now you're like, why is this important? Really, that's what you're supposed to do before you ever add, subtract, or divide. You're trying to show that I have the same number on both sides. So really in the geometry world, it's more stuff like this. We're going to say the measure of angle 1 is equal to the measure of angle 1. And we even use it more with congruency than we actually do with equal signs. But remember when you think of reflexive property, think of what word? Reflection, because you see yourself. So it's equal to itself. All right, next property that we have, this one throws people off, but you guys use it tons when you're in algebra or even in my class. So the symmetric property. Symmetry means it's the same on both sides, correct? So should it matter what side you're on? No. So if you have this, if A equals B, then this gives you permission to say B equals A. Let me give you an example of when this would drive you nuts and how some of you cannot stand this. What if you were solving an equation and you got something like this? If a -5 is equal to x. How many of you leave it that way? Those of you who leave it that way? Good, because you're wasting your time to do it otherwise. But anyway, those of you who can't stand it, what do? What gave you permission to do that? The symmetric property does. You do every time. There's nothing wrong with that, because are you actually doing, this sounds jokingly, but like a joke, but aren't you being mathematically correct to switch sides? If they're equal, does it matter which side? No. That's why those of you who have to switch all the time, I'm like, whatever. But That's fine. You're not doing anything wrong. And sometimes it helps to see things better by switching sides, right? So it's okay. All right, the next one is almost, I'm going to put this on here. This is kind of, it's kind of like LS. Does that make sense? It's kind of law's logisms or law of silly gizzards. It is called the transitive property. Oops, I thought I changed colors. So here we go. Transitive. For the transitive property, it's something like this. If A equals B and B equals C, then A equals C. Transitive property with equal signs isn't really as helpful as when it has a congruence symbol with it. But doesn't, can't you see like you have that chain? Basically, I always think of transitive properties like if I have a chain of things I want to go equal to each other. And I want to get out the middle ground. So in a quick example of this would be something like if the measure of angle 1 is equal to the measure of angle 2 and the measure of angle 2 equals the measure of angle 3, then what would I do? Yep, you got rid of the middle one. All right, so in that last column would be if the measure of angle 1 equals the measure of angle 2 and the measure of angle 2 equals the measure of angle 3, then the measure of angle 1 equals the measure of angle 3. All right, transitive properties is just like connect. It's really just connections, right? Very much like LS. But then the next one makes sense too. This one's called the substitution property. They are very similar. Understand, if you ever called the transitive property substitution, I probably would not take, if I took anything, it'd be like a slight point off because they're really the same thing. A lot of times I don't take any points off because it's saying the following. If A equals B, then A can replace B in any equation. Or could I say it the other way around? B can replace A in any equation. Right? You can just substitute it in. Let me give you an example of what I mean by this. Let's say the following. We know x is equal to 10, and I have this equation over here, x plus 5 is equal to y. If I'm doing substitution, what would I do with my x in that second equation, x plus 5 is equal to y? I'd replace it with what? Yeah, you would then know that 10 plus 5 is equal to y. Because what did I do? I substitute it in. So that's the real big difference, is a lot of times you're replacing it into another whole equation. We're just using substitution. Like football, like soccer, like any sport, you put a sub in and you pray they're equal. So they're, right? Those are those really awesome teams because like every player is amazing. Then you're like, Fred, they just put in, they didn't take a bad player out. They put someone just as good in. You guys know those are not fun to play against. No. You always hope, like, their best player is going to get injured, and then their backup comes in, and you're like, never mind, not a good day. Not that I'm competitive or anything, and that would bother me. Not at all. All right, last but not least, this one, you should all know, it's just the distributive property. So the distributive property with this one. With the distributive property, this is just reminding you, in order to get rid of parentheses, you have to multiply a to both terms on the inside. So I can get here, and that'd be a times b plus a times c. You distribute, or remember, guys, when you were first learning this, the teacher would draw what? Remember the arrows, the good old days? The good old arrows to remind you? Yeah, that'd be 5x minus 25. Guess what people do when they are in a hurry, especially in Geometry Advanced? They forget to distribute. Everyone's like, oh yeah, it's 5x. And they forget that it should have been multiplied by the negative 5, just the same. Now guys, is that really hard properties? You knew all of them, right? Maybe not the fancy names, but you knew every single one of those properties. Now, notice though, we have properties for what also? Congruence. Now, here's the cool part. Here's how you know if it's a property of congruence. There's only 3. Did everyone hear me on this? There's only 3. and they're exactly the same thing as any of equalities, but guess what symbol you're going to use instead? Yeah, you're going to use the congruence one instead. So there's 3 properties of congruence you're going to need to know. And we use these a lot. I would highlight this. Used a lot in proofs. Okay? These we are going to use a lot in here. So the first one is called the reflexive property. Now think about this for a moment. If the reflexive property of equality is you're equal to yourself, aren't you also congruent to yourself? Yeah, so you're going to see things like here, angle 1 is congruent to angle 1. Or you'd see something like segment AB is congruent to segment BA. What? What? You don't have to write anything but reflexive property on there. Because the rule isn't different than on the other page. It's just a symbol. Yes.
Why would you write that? It doesn't seem to help.
Well, because when you're talking about geometry, can a line segment be in 2 different figures? Or an angle be in 2 different figures? Think about it. Can I have a triangle right here, and this is A and this is B? Do you guys agree with me? It could be in this triangle right here and that triangle right there. So there's going to be times I'm going to be using it in that sense. I'm using it, yeah, it's the same thing, but I'm using it 2 different ways. Even notice how I wrote that a little bit different. Is that the same thing? Does it matter which one you name first? No, unless you're trying to prove congruency. And that's how I wrote it when I was doing congruency later. So, of triangles, not that segment. Yes, sir?
How do you know what the bars of the letters?
Because remember, an equal sign is saying that what its value is. Congruency also says, hey, they're same size, same shape. You're not giving me the actual traits.
Okay.
Equal signs give numbers. That allows you to do the algebra behind it. That's the big difference. All right, good review. All right. Symmetric property, this one doesn't really, you don't use it that much. I'll just admit it with you guys. It's just one of those things that, hey, if you can do it to one, you can do it to the other. If angle 1 is congruent to angle 2, then angle 2 is congruent to angle 1. Can I switch sides when needed? Yep. So reflexive is really important one we're going to use. And the other one is we're going to actually use the transitive property. This is, if in doubt, the transitive property is used most of the time with congruency. And it's something very simple like this. If angle 1 is congruent to angle 2, angle 2 is congruent to angle 3. Guys, what do you know? Yep, angle 1 is congruent to angle 3. Someone just said, that's LS. Yeah, that's LS. See, except for with LS, you can't switch sides. I can use transitive property, and I can sit there and say angle 3 is congruent to angle 2 and still call it transitive property because it's a congruency symbol. But LS, things have to be set perfectly in that manner. All right, now, this is what your homework is going to be like. A wise student would make sure to use their notes when they're doing this so they did it the right way. They don't call these formally proofs, but guys, guess what they are? Proofs. Because look what it says. Solve each equation, show all your steps, and what does it say right next to it? That's a proof, right? You're justifying why you did what you do to get the answer. Now, again, you could solve equations different from one another in here. So here's what you're going to do. On your homework, when they say to do this, you're literally going to do a 2-column proof again. Here's your statements. Here's your reason side. Now, when we were doing our stuff with direct proofs before, we always had to start with a premise, right? What other word did I use to describe that? Given. So when you're not doing it with direct proofs, you're going to actually just call it the given, all right? It means exactly the same thing as premise. So how did I have that equation? It was what to me? Given. All right, so that's going to be your first step. Now it's up to you to decide how we're going to solve this. What would you guys do first? Distribute. So I heard distribute. Did anyone else think differently?
Multiply everything by 5.
Yes. Yes. Guess what? Those of you who distributed, I think you're going to end up making yourself do more work later. But I'm going to do it that way because there's more majority of people who said that first. Oh, man, you guys make yourself go through a lot more work. But if you distribute, you got 1/5 A plus what? What's 1/5 of 10? 2 is equal to negative 3. And that is using the distributive property. Now, guys, someone asked if they could really abbreviate a lot. The one thing I tell people you can abbreviate is the word property. Obviously, addition is like add, prop. That makes sense that you can do ones like that. Reflexive is pretty easy, symmetric. But with substitution and subtraction, don't abbreviate because I'm not going to know which one you're talking about. So be very careful. But now, let's keep solving this equation. What do I do next? Subtraction, because I'm going to move what? Move the 2 over. All right, so that means I have to subtract it from both sides. Corbin, you have a question for me.
Yeah, I was wondering, do you have to write down what number we use, like what number?
No, because you're only using the one right before it. Because you're always using the one right before it. But if you did, it's never a bad habit. So on this one, we knew that was our subtraction property. All right, now what would you guys do? All right, are we done? Are we done solving? What symbol are you going to use? That doesn't go away. That lets me know you're finished. That lets me know you're done. I don't care if the book does it or not. You're telling me when you're done. Are you guys with me on that? So therefore, I know A is equal to a negative 25. What process did we use? Multiplication. Now, guys, that didn't take that long. But you do have to justify. This is one of the things you will do literally on your final is do a proof for me algebraically. All right, let's do this next one over. Here's my statements. Here's my reasons. Talk to me. What would you guys do first? Yeah, it's given to you because where else did that thing come from, right? Then what are you guys going to do? I'm going to change this to 2. All right. You're going to add 1.3. Okay. So you got t plus 7.8 equals 3t. And that is going to be my addition. Now, guys, you cannot use the addition property as a reason. I don't know why I didn't just say prop there. Unless you do it to both sides. Did everyone hear me on this? You have to do it to both sides of the equation to be addition property. You can always add, but that doesn't mean you're doing addition property, though. It has to be both sides. We'll explain a little bit what that would be. All right, what's the next one, guys? Subtract t, all right. So I get here 7.8 is equal to 2t. Subtraction property. And then we should get our last one here. What do we get? Actually, no, wait, we're gonna go another step because some of you have to do this. It'll drive you crazy if not. Divide by 2, right? So we get 3.9 is equal to t. Right? Division property. Now, the reason why I'm keeping this step is for those of you who have to do this because it doesn't make you happy otherwise. What am I going to do? Switch sides, which is what property? No, reflexive is if you're equal to yourself. Yep. This is the symmetric property for those of you who have to be able to switch. For most of us, we'd have been, I would say about half of us in this room, we're like, number 4 is a good stop for us. We solve for t, we're good. But those of you who always have to have it on the left, guess what step you need to include? Your life totally changed. Your life has totally changed now, hasn't it? All right, now, guys, this is what you're going to be doing today as well. Someone asked me, do I have to write the steps down? You know what? I do want you to write the steps down on your homework for this. And the reason why is I want you to see where it's coming from. Now, this is a lot of times what starts. Does that diagram look really familiar to you? Yeah. What postulate would you use in order to solve for that? Sum of the parts equal the whole, or the segment addition postulate, right? Guess what? You may write segment addition postulate or sum of the parts equal the whole. I'm good with either reason. But isn't that where I got it from? The diagram is given. The rest of it is actually work that we do. So with this one, you would sit there and say either segment addition postulate, or you may choose sum of the parts equal the whole, and I'm totally okay. I did abbreviate segment addition postulate. If I've shown it to you, what do you think? All right. Now, That came from just a diagram, a geometric diagram. So do you think your diagrams are able to give us information? What do you guys think? Now, look at the next step. How did I change from step 1 to get to step 2? No, it's not transitive. Transitive means I have to have a chain, and I didn't have a chain given to me. All of a sudden, I have the length of segment AG gone, the length of segment HI gone, and the length of segment AG. Didn't I substitute what I knew from my diagram? Yeah, that's substitution property. And it really did. The substitution came from, I know what those segment lengths given on my geometric diagram. Now is the rest of it very much how it feels like algebra now. So what do we do next? There's no distributive property on that one because it's a positive one, so you don't really have to follow that. What did I do to that right side? It's not addition property though, is it? All right, but believe it or not, add's not going to go with me anymore. There's actual fancy word you could use for this. It's real simple. It's called simplify. Did I simplify on the right side only? Yes. The other word you could have used was combine like terms. Either one of those would be reasons I would accept. Because did I combine 2x and 3x? And did I combine 6 and -3? Now, guys, you should always combine like terms before you solve any equation. This is a great process to remind you. Quit moving stuff until it's simplified first. Then start moving on which side, the different sides. Always simplify first. Now what happened? How do I get from step 3 to 4? Yeah, we did addition property. Very good. Now this one's the addition property because I added 3 to both sides. All right, how do I get from step 4 to 5? Yep, we're subtracting, so we have our subtraction property. Here's the thing, guys. If you don't say property, I won't believe you that you added to both sides. Because you can add on one side, right? And then last but not least, therefore, x equals 3 by the division property. Guys, is this really that hard? No, it's really simple. It's, in some ways, it's simpler than our direct proofs because direct proofs, we always had to look at 2 things before we did this. So it's not too bad. All right. Here's some other stuff you need to do that will help you on some of your quiz and stuff on Monday. By the way, you have an online quiz for off-campus learning day. You can use notes. That's it. But it's a quiz grade. Quiz grade. All right? So just know, and you only get one shot at it, so you want to make sure you do a good job. All right, now let's identify the properties that justifies each statement. Let's go. If M equals N, so N equals M. What property is that? Reflexive is M equals M. This is symmetric property of what? This is symmetric property of equality. Because remember, there's 2 different types of symmetric properties. There's congruence and equality. How did I know of equal sign? Right? Congruency symbol, are you going to throw away most of your equality ones, right? Now, look at B. Those of you who were talking earlier. ABC is congruent to angle ABC. That's which one? Reflexive. Very good. Yep, reflexive property of congruency. We're just going to use the congruence symbol as our abbreviation. Are you guys good with that? Look at the next one. Segment KL is congruent to segment LK. Right away, you know you only have 3 choices. It's reflexive because what it's emphasizing is the fact that's the same segment. So this again is the reflexive property of congruence. Now look at the next one. If P equals Q and Q equals -1, so P equals -1. I would take substitution. I prefer a different name, but substitution would get credit. It's really the transitive property. I can't spell transitive all of a sudden, though. It really doesn't help, does it? Of equality. And the reason why, this one looks very much like a chain got put in place, right? Substitution a lot of time is like I'm substituting into another whole equation. But if you said substitution, I would still give you credit. Did you guys still hear that? But only would give you credit if it's for equality. If you told me substitution with a congruency sign, you totally got it wrong. All right. Now I want for you guys to do this on your own. Do 1 through 6 on your own, and then we will put choose the best answers. Now, Guys, let's just use some common sense on some of this stuff. If there's an equal sign, it better be the property of equality, right? Like, if there's not, I'd be a little concerned. But like on number 1, what's your answer for that one? B, yep, it's subtraction. On number 2 there to the right, that's J. Guys, doesn't that look really familiar to like the work backwards problems we did for finding the endpoints of midpoint of line segments using the midpoint? It's a very similar process. Here on number 3, it says if 5 equals 2k, what justifies 2k is equal to 5? What happened? Symmetry, right? It switched sides, so that's the symmetric property. Guys, those of you who keep saying reflexive, 2k is not 5. 2k would equal what? 2k, or 5 equals 5. Reflexive means you're looking at the same thing. Exactly. 4, make sure that when you work with this one, you're trying to use the distributive property. Make sure you don't forget some very simple algebra stuff that you're doing. Because remember, what's 2a times a? 2a squared, and then 2a times a negative 4. Make sure you are using your distributive property carefully and your algebra is good, right? Make sure our algebra is good. That says, which completes the statement? If 6x equals 5 and d is equal to 6x, then blank by the transitive property of equality. Basically, aren't we just going to be getting rid of which one? The 6x. Notice it doesn't have to be like when we do LS, the rule LS, where they have to go perfectly like in the middle. It doesn't have to happen with transitive property. That's where they're different. And then 6, it says, which completes the statement? If segment RS is congruent to segment GH, then blank by the symmetric property of congruence. They switch spots. Symmetric property means they switch sides of the symbol. All right, does that make sense? All right, so let's use the rest of class time here. A good chunk of you are going to get a lot of your homework done because we still have a good, it's like almost 20 minutes. Almost 20 minutes. A little bit less. It's about closer to 17 minutes to do this. Sound like a plan? It's online.